Okay, let's look at this review problem. First off, we're going to show with a Venn diagram that the complement of A intersect B is the union of A complement and B complement. This one is actually not the easiest one to show with a Venn diagram, so we're going to do this one in stages. First, let's take a look at the right-hand side. So here's a Venn diagram. So here's A. Here's B, which may intersect A. And I'm going to color in red, at least try to color in red, A complement. So A complement will be everything that is outside of A. So I'm going to color in red going like this, everything that is outside of the A circle. So that's what I'm shaded in here. That is A complement. Now let's do another thing where I shade in B. So for B complement, I'll do this one in blue, or at least try to do it in blue. That one didn't work, so I'll do it in black. B complement, I will shade everything that is outside of the B circle. So I'll shade, and if it's outside of the B circle, I'll draw another hatch but going the other direction. So all of this, and let me put in some extra hatches just for the sake of clarity. So if it's outside of the B circle, we shade. Now, where's the only place that isn't shaded? The only place that isn't shaded is going to be the thing in the middle. So I'm going to highlight that in pink. This part here is the only part that didn't get shaded by at least one of the hatches. So if I take the union of the A hatches, the A complement and B complement, then I shade everything except for the intersection. So that's going to be the everything except for the intersection. So A intersect B complement. So that's a visualization of why this one works. Now that is a visualization, not an actual proof. So now let's go through the proof of why this works. So theorem that A intersect B complement is equal to A complement union B complement. So we'll do this two different ways. So we're going to do two things. We will show that A intersect B whole thing complement is a subset of the right hand side, A complement union B complement. We'll show that first. We will also show that A complement union B complement is a subset of the left hand side, A intersect B complement. If I can show both of those, then that proves that the two sets are equal. So first, this one. So part one, or step one. Suppose that X is an element of the left-hand side. I want to show that X is also an element of the right-hand side, and that will establish that the left is a subset of the right. By definition, X is not an element of A intersect B. So it is false that X is in A and X is in B. That's what it means to not be in the intersection. It's false that X is in A and X is in B. Therefore, the negation of this statement is true. X is not in A or X is not in B. If I take the negation using De Morgan's laws. It's false that this is true with and therefore the negation. So if P and Q is false, that means not P or not Q is true. By definition, if X is in this by definition, if X is not in this set, that means that X is in A complement or X is in B complement. That's what it means for x not to be in A, is that x is in the complement of A. And by definition of union, that means that x is in the union of A complement and B complement by definition. Part 2. Suppose that x is in the union. A complement union B complement. Now I'm going to kind of run the logic that we just did here, but in reverse. By definition, x is in A complement or x is in B complement. That's what it means to be in the union. It's in one set or the other, and possibly both. So that, therefore, by definition of complement, x is not in A and x is not in B. Or x is not in B. So x is not in A or x is not in B. Okay, so it is true that x is not in A or x is not in B. So it's false that x is in A and x is in B. This statement is true, and therefore the negation is false. It's false that x is in A and x is in B. That is, it's false that x is in the intersection of A and B. So if x is in A and x is in B, that's the same thing as saying x is in A and B, A intersect B, and that's false. Therefore, x is not an element of A intersect B, so it's false, or x is an element of the complement of A intersect B. Okay, so we've established that the left is a subset of the right, and the right is a subset of the left, and so therefore the two sets are equal. And so that's the end of the proof.